Hello, hello. We're moving on to lesson 2.2 and we're going to talk about linear relations and functions. So we're talking about straight lines. How do I identify a linear relation? How do I identify a linear equation? How do I identify a linear function? How do I write a linear equation in standard form, and how does that help me find the x and y intercepts that makes graphing super easy? So those are the questions we're going to answer today. We got a lot in here, jam-packed. You ready to go? Here we go. A linear relation. Graphs are straight lines. Straight lines. A linear relation, you can tell it's a linear relation because the graphs are straight lines. That means you can't have a U, you can't have a V, or you can't have a curve like a odd function. If you have a linear equation or a function, all right, when you're looking at an equation or a function, you can only have operations of addition, subtraction, or multiplication of a number and a variable. Okay? You cannot divide by a variable. You can divide by a number, but you cannot divide by a variable. Cannot divide by variable. Then it's not linear. Variables cannot be multiplied together because that would give them a power of 2. And all variables must have a power of 1, no greater than 1, no less than 1, exactly 1. Variables cannot appear in the denominator. That's because we can't divide by it. Remember, simplify before you classify, before you decide whether it is a linear equation function. 1 through 4, the top ones, these are what linear equations or functions look like. Notice that on this first one, x is to the first power, y is to the first power. I'm only multiplying numbers and letters. I'm not dividing. I have a subtraction sign, okay? My constant is moved to the right. X equals 10. Remember that oh, this comes later. X equals 10. It's to the power of 1. This is a vertical line. Vertical line. Y equals 3x to the first minus 2 all over 4/3. Both of my variables have powers of 1. I can divide by a constant. This is okay. I cannot divide by a variable. Y equals x divided by 2. I can divide by a constant. I cannot divide by a variable. These examples down here are what linear equations do not look like. 2x plus 6y squared. I cannot have y squared. Y equals the square root of x plus 2. This is like x to the 1/2. I cannot have a power of 1/2. It can only be 1. Number 3, I cannot have two variables multiplied together because that gives that term a power of 2. Number 4, I cannot have a variable in the denominator. I cannot divide by a variable. Okay? I can divide by a constant, but not a variable. Linear functions follow the exact same rules as a linear equation, so we're going to state if this is linear or not linear and why. All right? F of x, that's the same as y, first power. Look at where my x is. It says a first power, but it's in the denominator, so it's not a function. I cannot divide by a variable. G of x is equal to 1.5x plus 1. Everything's good. My powers are 1. I'm just multiplying by a number. I'm adding a number. This is a linear function. Erase that. That looks crumbly. H of x is equal to x cubed plus 3. Y equals. That's the same thing as y equals. I cannot have a power not equal to 1. This is not a linear function. All right, standard form of a linear equation. Mrs. Abeg went over this last year. Ax and by terms must be on the same side of the equal sign. Moving both of them to the left is very helpful. Coefficients must be integers, so that means if you have a fraction, you've got to multiply every single term by that denominator to get rid of that fraction. Then you have to divide through by a greatest common factor. You have to reduce them down to their lowest form. The coefficient a must be positive, so you may have to multiply everything through by a -1. And a and b cannot both be 0. One or the other can be 0. So you can have x equals 10 and that be a standard form, y equals 5 and that be a standard form, but you can't have just a number, okay? Write in standard form and then identify a, b, and c. We got to move that x to the right. So I have -4x plus 2y is equal to 5, okay? I need to multiply everything through by a negative, so I have 4x minus 2y is equal to -5. I don't have a common factor for all three terms, so I'm leaving it as it is. A is equal to 4. B is equal to -2. C is equal to -5. On number 2, I have to get rid of this fraction, so I'm going to multiply every single term by 10. So I get -3x is equal to 80y minus 150. I'm going to move my 80y over. -3x minus 80y equals a -150. 3 doesn't go into -80, so I'm just going to multiply everything through by a -1. 3x, it flips my signs, plus 80y equals positive 150. So a equals 3, b equals 80, C equals 150. That's how you write it in standard form and identify A, B, and C. X-intercept is the ordered pair, any number, that's why I called it x1, x sub 1 comma 0. It indicates where it crosses the x-axis. Another name for the x-axis is the line y equals 0, because every y-coordinate on the x-axis is 0. The y-intercept is the ordered pair 0, comma b. All right, this is the y-coordinate of the y-intercept. We get that from the slope-intercept form. It indicates where it crosses the y-axis. Another name for the y-axis is the equation x equals 0, because along this axis, every x-coordinate is 0. When you're in standard form, it is the easiest time to get that x and y intercept, and it just makes graphing super easy. It's a snap. To find the x-intercept, you're going to plug 0 in for y, solve for x, write it as an ordered pair. To find the y-intercept, you're going to plug 0 in. Oh, I think I might have said 0 in for x here. 0 in for y, solve for x. All right. To find the y-intercept, 0 in for x, solve for y. Make sure you pick up that sign in front of y. That's where a lot of students make their mistakes, and you're going to write it as an ordered pair. So let's do some real quick. Write in standard form. So don't worry on this. Don't worry so much about getting a positive because that'll come out in the wash, but you got to get the constant on the other side. So negative 2x minus y equals, I don't know why my pen does that, equals positive 4, okay? Put 0 in for y, that's like covering up y. Just pretend it's not there. Negative 2x is equal to 4, x is equal to negative 2, so then we have the ordered pair negative 2, comma 0. Always write it as an ordered pair. That is my expectation. Always write. Do not say the x-intercept is negative 2. No, it is not. It is not. It lies on the line x equals negative 2, but the x-intercept is negative 2, comma 0. Negative 2, comma 0. Find the y-intercept. We're going to pretend that x is not there. That's another way of plugging in for 0 for x. Solve for y. Look at how I made sure I gathered that negative y right there. So I get negative y equals 4. So that means y equals negative 4, and I'm going to put it in ordered pair, 0, negative 4. Write that ordered pair. Write that ordered pair. It's not y equals negative 4. That is a line, the vertical line that the y-intercept lies on, but the y-intercept is 0, negative 4. Okay? All right. Now we're going to use this technique and we're going to find the x and y intercepts and graph 5y minus equals negative 2x minus 10. I'm going to get my x over to the other side by adding. I'm going to find my x-intercept. So 2x equals negative 10, x equals negative 5, so that is negative 5, 0. My y-intercept is 5y equals, what is the deal with my pen? Hate that. 5y equals negative 10, y equals negative 2. That is the point 0, negative 2. So I'm at negative 5, 0. Sorry, I'm about to cough. And 0, negative 2. And I connect the, well, I missed by a long shot there, didn't I? And there's my line, just like that. Piece of cake. All right, here's your daily assignment that we're going to work on tomorrow. If you feel like you want to get a head start, go for it. Make sure you save some or come with questions, and I'll talk to you tomorrow. Thanks.